All right, let's jump right into one of the most fascinating puzzles in all of science and philosophy. It's a paradox that puts our own common sense in a head-to-head battle with the cold, hard rules of logic. And trust me, it's gonna get a little weird. So let's just put the main question right out there. It sounds absolutely ridiculous, doesn't it? I mean, what on earth could a piece of fruit have to do with the color of a bird that might be thousands of miles away? Well, believe it or not, according to a very strict line of logical reasoning, it has everything to do with it. To figure out how we ended up in such a strange spot, we first have to lay out the basic facts of the case. We're going to start with a really simple statement about birds, and then we'll see how logic takes it for a very, very unexpected ride. Okay, here's our starting line. A simple, straightforward, scientific-sounding claim. Now, if you wanted to test this, your first instinct would be pretty obvious, right? You'd go out and start looking for ravens to see what color they are. You know that common sense idea actually has a fancy name? It's called Nycode's criterion. All it really says is that to confirm a rule about a certain group of things, in our case ravens, you should go and actually observe members of that group. Seems perfectly reasonable. And this is exactly how it works in practice. You see a raven, and hey, it's black. Your belief in the hypothesis all ravens are black gets just a little bit stronger. Every single black raven you find adds another little piece of evidence to your pile. So far, so good. Our intuition and our logic are getting along just fine. But this is where things start to go off the rails. It turns out our simple little hypothesis has what you might call a secret twin. It's a statement that sounds totally different, but in the world of formal logic, it's treated as the exact same thing. So here they are. The statement, all ravens are black, is considered logically identical to all non-black things are non-ravens. The second one is called the contrapositive. And if you think about it for a second, it makes sense, right? If every single raven in the world is black, then it must also be true that if something isn't black, well, it can't possibly be a raven. They're just two different ways of saying the same thing. And this is the absolute key. In logic, this isn't just a clever word game, it's a fundamental rule. If one of these statements is true, its twin has to be true. If one is false, the other has to be false. They are completely locked together. And it's this unbreakable link that really opens the door to the paradox. So think about what that means. If two statements are logically identical, then any piece of evidence that supports one of them has to, by definition, also support the other one. And that is how we get our very, very strange clue. Let's just walk through this one step at a time. First, we accept that those two sentences are logically the same. Okay. Next, you're walking along and you see a green apple. Well, that green apple is obviously a non-black thing, and it's also a non-raven. So that green apple is a perfect piece of evidence that confirms the statement, all non-black things are non-ravens. And since that statement is identical to all ravens are black, observing that green apple just provided evidence for our original hypothesis about ravens. Yeah, it's pretty mind-bending. And this right here is the battle raging in your brain. Your intuition is just screaming that an apple has absolutely nothing to do with birds. But formal logic is sitting there, cold as ice, replying that if two statements are the same, they have to be supported by the same evidence. Something's got to give. So, how do we escape this logical trap? Well, philosophers and statisticians have come up with a few really clever ways to resolve this conflict and, bring a little sanity back to how we think about evidence. Let's dig into the most popular solution. The most widely accepted answer comes from something called Bayesian reasoning. The core idea here is that evidence isn't just a simple yes or no thing. It's not a light switch you just flip on or off. Instead, confirmation comes in degrees. Some evidence is really powerful, and some is incredibly weak. And this visual explains exactly why that distinction matters so much. Just think about the number of non-black things in the entire universe. I'm talking cars, grass, planets, apples, everything. It's an astronomically huge number. The number of ravens, though, it's tiny in comparison. And that massive difference is the key to the whole thing. See, when you find a black raven, you've successfully tested one member of that very small and very specific group. That observation makes a real dent in the possibility of finding a non-black raven, so it gives you a strong update to your belief. It's a really potent piece of evidence. But on the other hand, finding a green apple, well, it does technically confirm the rule. You've checked one item off that colossal, nearly infinite list of non-black things and confirmed it isn't a Raven. But because that list is so unbelievably gigantic, the impact it has on your belief is practically zero. I mean, to put a number on it, the confirmation you get is so ridiculously small, it's basically a rounding error. So what the Bayesian solution says is that our intuition isn't wrong, it's just correctly recognizing that the evidence from the apple is so incredibly weak that it's just not worth our attention. So logic is satisfied and our common sense is saved. Now, there is another way to look at this whole problem, which was championed by the philosopher Karl Popper. This view, it's called falsificationism, and it basically argues that we're asking the wrong question in the first place. Science doesn't, and really shouldn't, move forward by just piling up confirmations. From this point of view, the real action is in trying to break the rule. You could see a million black ravens, and it still wouldn't prove the rule is true for all time. But finding a single non-black raven, say a white one, well, that falsifies the rule instantly. It's game over. So the green apple is completely irrelevant because it has no chance of ever disproving the hypothesis. So, what's the big lesson from getting lost in this logical maze? Well, the Raven paradox isn't just some clever party trick. It's actually a pretty profound lesson about the nature of knowledge itself. This whole puzzle really teaches us that when our gut feeling clashes with these formal rules, it's not a bug. It's a signpost pointing to something deeper. It shows us that not all evidence is created equal. The weight of it matters. Context is everything. And finally, it reminds us that science isn't really in the business of proving things true, but more about relentlessly chipping away at everything that could be false. I think this quote just sums it up perfectly. The paradox isn't a mistake in logic. It's more like a feature, a built-in warning light, telling us that the word confirm is way more slippery and complicated than we usually think. And that's really the heart of it. We don't solve the Raven paradox by declaring that logic is broken. We understand it by realizing that it has revealed something incredibly important about the relationship between evidence, our beliefs, and this vast, complicated world we're all trying to make sense of. And all of this leaves us with one last big question to chew on. In situations like this, where pure logic leads you down one path and your deep-seated intuition is pointing in a completely different direction, which one should you ultimately trust? The rules we've created or the sense that guides us? Thanks for tuning in.